main question that lighting engineer will ask is how I can use technology, any kind of technology, in order to be able to illuminate correctly a space. That you have in mind that lighting has, of course, a lot of positive effects, but also if you your lighting design is bad, then you can have some problems, and you have a list of those problems, and the list is not exhaustive here. First of all, if you don't see correctly what you are doing, your productivity will decrease, and your boss, of course, will be not happy. You may experience perturbic reflections on walls and work tools. Your question about mirrors is exactly here. Usually you don't like such kind of reflection. We can have a dazzling and glare, which is also very problematic. We can have a flickering light effects that express as headaches up to epileptic crisis or fatigue, strain, eye strain, and global fatigue. This is also something happen, and also circadian rhythm disruption. What is circadian? Circadian is our internal clock that is fixing our wake up and sleep cycle every day, and you will see that this clock, it is readjusted every day thanks to the light variation, natural light variation, of course. And now if we are living far from the natural lighting, that could be an issue. Here is just to illustrate what I said. Lighting can increase our performance. You see here, this is the error rate when you read something. What is the error rate per page? How many words you misread? And you see that the error rate is decreasing very rapidly with the level of illuminance on the book. And you see something interesting, around 1000 lux, which is a lot of light. Here, this is stabilized. Okay? This is stabilized, and even if you increase more, you can go to the other direction. Same thing here. You have the productivity increase as function of the illuminance in lux when you have to perform a simple task or a difficult task. And here is the percentage of workers per worker declaring fatigue. And same thing, you see that the fatigue reduce as illuminance increases, both for simple or difficult task. Globally, when you increase illuminance, you increase all the performance, but be careful, don't go above a given quantity of light, because in that case, the result can go to the opposite direction. To understand that, we need a little bit more definition, and something more important here is that we call the contrast. The contrast is the luminance variation between a detail, the black dot here, and the background around. If you have the two luminance, detail and background, then the contrast is defined as you see here, detail luminance minus the background luminance divided by the background luminance. And you can have good contrast or poor contrast, as you can see here, but the contrast can be negative. Here the detail is, the characters is less bright than the background, or positive background. Here the detail, the text is brighter than the background. We don't care if we are in a positive or negative, but passing from good to poor and vice versa, this is, has important impacts to our capacity. And here I will explain you something that most probably know all of you, but to experimental way. To explain our visual performance, we have a matrix which is the visibility level, VL, called here, and this visibility level has been studied by the CIE, the International Committee of Illumination, and they define 12 visibility levels from 1 to 12. When you are in visibility level 1, what is your task? For every trial, you have a 50% failure rate. One trial or two trials, one is false. Okay? This is the real minimum. And 12 is a very high level. The error rate is very small, less than 1%. And this one, the level 12, is required when you are working with a computer or with screens. You will understand why. And you see that these levels here depends on the contrast and the background luminance. Okay? It is globally not advised to have a contrast higher than 10. This is logarithmic. If you have contrast higher than 10, then all the objects that will be with that contrast will be dominant. You will see only that. Here, the screen is rather bright, but is not so bright in order to be dominant. But if I look the lamp, here the contrast between the lamp and the roof makes that the lamp is dominant. My eye will look automatically the lamp, not the roof. And now look here, when you are performing a task, there are two options. One is that one, passive visual task. That means you read a book, for example, and what happened in the book, what is the contrast? The contrast is the printed characters with a given ink on the top of a paper with a given reflection coefficient. That means the reflection coefficient of the detail and the paper is fixed by the manufacturer, not by you. That means the contrast is fixed whatever is the illuminance or the luminance level. Okay? And look here what happened. For this task, the contrast is fixed. For any luminance, that means what? If you are in a very bad reading condition, say you are somewhere here for reading for visibility level less than 1, how you can enhance the visibility level? Just you light up more your book. You know that effect. All of us, when we was young and we want to kids, and you have to go to bed early and you want to continue reading your book, or I don't know what usually kids do, they continue reading without light. And then you heard your mother telling, don't read in the dark because you will damage your eyes. You will not damage your eyes, but you will create additional fatigue for your eyes. And you know also this phenomenon when you arrive to my age and you go to a nice romantic restaurant that is illuminated with candles. You don't have enough light to read the menu, especially if the menu has not good contrast. And what all people is doing, we take our mobile phone, we switch on the light, and then you can read. You don't need to have glasses. Just because of that, because the contrast is constant, and if you overlight, you increase the visibility level. This is very simple. But it's not necessary to go beyond 12. Beyond 12, you don't want anything else. A second kind of task is that we call active task. You are working with something that produces its own light. This is the case of your mobile phone, of the GPS, of your screen, of I don't know what. And these kind of devices, they have that behavior. That means when you increase the light coming into a screen, you decrease the contrast. You destroy the contrast. And that means what? If you have a very old computer or an old device with a very degraded screen and you don't see very well what is written in the screen, then don't overlight the computer. On the opposite, you have to put something to cut the parasitic light in order to be able to pass from low levels to go to high levels. You have to cut the parasitic light. You have to put the computer in the dark. And all of us, we like very well looking TV in dark space, but because the contrast is higher. But if you do that, your eyes, as the TV is dominant, will fix the TV, and your muscles here, you will get fatigue because you don't move enough your head. And some TV set manufacturers, they propose screens with a little bit ambient light behind the screen in order to light up a little bit the space that allows you to look all around, and you reduce fatigue, but you keep the contrast as high as possible. If you go to the cinema, you are also in a dark room. It's unusual that the films is more than 2 hours in order to reduce fatigue. On the other hand, the screen is huge and you are very close to the screen. In any case, you have to move your head, okay? Now from the visibility level, how you can define a visual performance rate. This is very difficult. In fact, the visual performance rate is defined as the product between the accuracy, you execute a task, if you read a text, how many words you miss or you misspell per line or per page or what you want. If you are screwing a screw, how many screws you don't do it correctly. I don't know, well, this is what you are doing, how many errors you make, and what is the speed of the execution. How much time you need to read a page with a given number of errors, and the visual performance is the product of the two. In fact, more you are performant, faster you go with the less errors. This is the idea, but the problem is this visual performance depends on a lot of parameters. The first, luminance adaptation, the luminance that you have around you that allows you to fix the level of your eyes. Remind our eyes, define what is the luminal level here, and make visible something 1 order of magnitude higher, something 1 order of magnitude lower. If you are low or higher, the object disappears, okay? You need also to take into account the contrast between the page and the characters, between the page and the table, okay? The spatial distribution of luminance. Here, in your block, the luminance is apparently uniform, and this is the objective. But now, if you have shadows and some bright and less bright areas, this can affect your visual performance. The angular size of the detail, that means what is the size of the fonts, for example, in the book, or the size of your letters. What is the size of the small component that you try to manipulate, or the small screen, for example, if you work for watches, what is the size of that stuff, and the angular size means that. Is the organization of the space, how you put your elements around you. I remind you that the micro is not in the domain of my binocular vision. I need to turn my head to see where it is and go touch it. But if I'm working here and I turn to find the other, I lost time there. I reduce my execution speed. The spectral composition of light is very important. Also, what kind of white light you use, warm, cold white, or color light can play a role. Also, the polarization of light. This is very difficult to understand because humans, we are not really sensitive to the polarization. You know that the sunlight or the artificial light is not polarized. The oscillation of the electric field and of course the magnetic field is at any direction, but once natural light or artificial light is reflected, especially in the case of mirrors, water, or specular reflection, then the polarization changes. Birds, they are very sensitive, birds and insects, they are very sensitive to polarization. They use that for their travel in the space. For us, it's not the case. The only thing that you know very well, if you take polarizing sunglasses, you can cut completely the reflections. And this is much more pleasant for you. And that means if you use somehow the polarization, you can increase the speed. The age is important. I told you that till 20-year-old, our visual field is maturing. And as you will see later, after 30-year-old, we start to become old. And we need more and more light in order to achieve the same task with the same speed and the same error rate. Depends also on permanent or temporary anomalies of the vision. I show you the vision of colorblind people with Daltonian. If you cannot see red and they ask you to work with red stuff, it will never work. And also depends on our societal learning and also the history of the individual. Remind the small image that I show you in the bottle. Kids don't see the same thing than adults. And of course the problem is when you have a such problem and someone tells you I don't see the same thing than you, then you can pass several minutes to try to understand why the other sees something else than me. Okay? There is a single model proposed by Mark Rea in the 80s that relies only on two parameters, the luminance and the contrast. And what says that model? Very simple thing. When the luminance is lower, you have lower performance. When the contrast is lower, you have lower performance. And then you have the maximum, a plot of the performance here. And after that, you can see a little bit here the behavior. You may have a decrease of the performance. Also, again, it confirms that no need to go to 100,000 lux like outside to be able to make your work correctly inside. This is visual performance and age, and you can see here as function of the illuminance level, the visual performance for difficult tasks, average difficulty task, and easy task. And you see that in any case, young, they perform much better than elder people. For any quantity of light going up to almost 100,000, from inside to outside, young people, you are better than older. Here, what I was saying before, our visual acuity matures and visual field also with age. And from 30, we are starting losing some visual performance. And in order to achieve the same visual performance, we need more and more light. It happens that around 70, the phenomenon seems to stabilize. And even some very old people, they are telling that they can recover some visual capacity. And I have seen with my eyes that the grandfather of one of my cousins, 80 or something year old, was reading the journal without his glasses. And I told him he can do that. I was young at that moment. I didn't knew the problem. I asked him, you can read the journal without glass? He told me, yes. Since some years I can do it. The question is most probably the visual performance of your eye don't change, stabilize, but the training, he was reading the journal every day. By training, he arrived to compensate the problem of the visual system. How much light is needed to perform various tasks? Here, there are a lot of works since 900, since the existence of International Commission of Illumination, CIE. They are working on that. And you have a lot, thousands of papers from more than 100 years now, dealing with different experiments, different models, different assumptions, and we have so much experience today that we are able to say, for example, if I want to have something that is well visible in corridors, changing rooms, in store, that I used to have casual seeing, 100 lux is enough. If I have a visual task with moderate difficulty, like general office, kitchens, laboratories, retail shops, 500 lux is enough. And if I have exceptionally difficult task, like assembly of very small items, finishing the work doing for your watches and things like that, then maybe I need 2000 lux. We have now tables like that they are internationally accepted, because also our origin, excuse me for the word, our race, race doesn't exist, but we understand what we speak for, plays a role. Also the color of our eyes plays a role in our visual performance. And we know that these kind of values, they are acceptable and they are well adapted to this kind of task for any kind of person, white, yellow, green, red, with blue eyes, with dark eyes, with clear eyes, male or female. They are universal values. Okay, in fact, this amount is needed varies in the development of the type of task to be performed, the type of surfaces also, where you execute the task, the general work area, the environment also plays a role, and also our personal vision. Okay? In any case, go above 1000 lux, except very exceptional cases, is not advised. Okay? Usually indoor lighting for average task everywhere, we use something like between 200 and 600-700 lux. It's very unusual to go to much higher levels. Fortunately, because I remind you, we are programmed for several thousand, even 100,000 lux when I'm outside in the daylight, but outside is a huge space. Here the volume is much smaller. I don't need so much light. The quantity of light that I need is inversely proportional to the volume that I have to eliminate. Well, okay, I show you some general accepted values, but be vigilant, because if you take different recommendation, this is from the Illuminated Engineering Society of North America, this is a French Institute for Working Security, this is, I forgot to put which organism is, you can find for the same task different values. Not very different, but you can find different values. Which one you have to take? Any of those. It's better to take the values that are generally accepted to your country, because if there are differences between the European and American or European and Asian recommendations, there may be some reasons, some fine-tuning. But in any case, it's very different to find more than 100 to 150 lux difference for the same task. Okay. In US, you will find always higher values because they want to show that they are richer than the others, but they don't really need it always. Be careful also, we are speaking in lux. The only country speaking in another unit is US. They are speaking foot candles. That means candle, lux is candle, candela per square meter. The other is candela per foot, per square foot, and they call that foot candela. Okay, this can be confusing, and globally, 1 foot candela is equal to 10 lux. Okay. Then you have also to look, okay, I have the recommendations, but in some cases, like in France, for example, legal constraints may apply. In France, in the workspace legislation and the law for working people and working areas, it includes a section concerning lighting. And that section, you have here the name of the articles of the law. It tells you that you have to avoid, of course, to kill people or to harm people. You have to avoid any nuisance in the space. And they give you some values here, which is very low. For example, look, for corridors, 100 lux. The recommendation before was telling 40 lux. Here the recommendation was telling 100. Yes, but this one is the lowest value. If in a working space you have less than that, for example, if in the working rooms you have less than 120 lux, even if the recommendation is around 300, what may happen here? If one of the employees complain, then they are that we call the work doctors, work medicine. They are mandated by the authorities. They can come. They will make measurements, and if they found that in the room is less than 120 lux, they will give a fine and will impose to make the rectification of the system within a couple of months. They will come back in a couple of months, and if the rectification is not made, they can completely close the space, forbid the use of the space. Well, fortunately these values, they are really low, but you don't have to go lower than that. If you use those values, you will not see anything, believe me. Also, this is also a French concept, which is unique. I don't see that anywhere else, but it is very interesting because in France we have that we call a standard with an X. Standard X something means experimental one, which is not transposed in a supranational level, stays valid only for France. And this standard go to in addition with the European and French standard for interior lighting, the L12 464. And for example, this experimental standard tell you how much light you need in reality. And for example, say that we are in the case of a space that I need 150 lux, follow the European standard, okay? Now, I will have to ask, following the French NFX 35103, I have to ask 5 questions. First question, errors in perception may have dangerous or costly impact. If you answer yes, then you increase by 50%. You pass from 150 to 200. Then you arrive in a second question: are the reflection factors and contrast low? That means if you are in dirty environment or with less light, if you answer yes above a value, then you have to increase the etc. Here the answer no or doesn't apply. I continue. Then question, an error, sorry, I forgot. The first one is if you have people, the error is there. The first question is, do you have workers with more than 45 years inside? And here we speak only the workers, not the visitors. If you are in a university, the clients, you are less than 45 years usually, but the worker is me, and usually we are more than 45 years, at least for a large part of us. We are prevailing to the non-permanent permanent staff. And here goes the question: error equal danger. If you don't see a drill and you put your hand, you will drill your hand. This is problematic. If yes, you increase. And then you have a single question that allows you to go higher. Is in that room the work performed occasional? If you just go to a storage space to put something or get something for the archives, then you can reduce the luminance, the illuminance, sorry, by 50 lux or something like that. And you start here from 150, and if you look those answers, then finally you have to put 300 lux. Another point which is very important, I told you that, is what is the uniformity of the illuminance in the space. The uniformity is defined like the average illuminance level, the ratio, sorry, of the minimum illuminance here divided by the average. You take the average here and you divide by the minimum. The minimum should be somewhere there. And in many cases, they told you that this uniformity has to stay higher than 80%. That is no more 20% less light there than the average of the room. And this can be problematic because if this is written in some rules, that means in that conference room, if I want to respect the uniformity, I have to switch on the lights there. And I don't need it. Well, fortunately, the new European standard says that you can define the working zone. Then here I can define that the working zone is here, and I look what is the uniformity in that area. I don't take care of that part which is not used at that moment. And you have here examples from different recommendations. For example, if I take a craft room, I need 300 lux with at least 50% uniformity. If I'm working a CAD workstation, I need 500 with a uniformity of 60%, but in the workspace. What is the space to be lit? I remind you again the different visual fields. This is coming from that. And the first thing when you look this person here working his antiquated computer, we don't care about that. You have a small spot there. This spot is that we call the foveal zone, that is just in the line of sight of our eye. And this is the area that you can see best the colors, remind that. And also at best you can see the smallest size elements. Then you have a second area, which is that we call the attentive wedge, which is around 15 degrees. That is that one, something like that. And this is the area that you can see a space without moving your eyes or your head. If you take your mobile phone and if you put it in 20 centimeter, this corresponds almost, especially like that, to your attentive watch space. You don't need to move your head or your eyes to see what is in the telephone. Now, if you take a screen of, I don't know, 40-inch diagonal for your computer, and you have it in 20 centimeters, you have to move continuously your head. Then you have the induced impression area, plus or minus 50 degrees. That means you are there really in the central vision part that you have binocular vision, and in that case, how you put your elements in your desktop is very important for your performance, but this is something that no one can tell you how to do it. You organize your space as you want, but you organize your space in order to be more efficient. And finally, you have a fourth space, which is the side vision, the peripheral vision. Here, in fact, when I'm here, I don't care really about what is around, but I know that there is a door here, there is a window there, and who knows, maybe one of the Hindu mythology monsters can attack me, or if I am in Nepal, a Yeti may arrive, and I am in danger. That means I want to have some light here in order to be able, if something moving there, to look who is and what you want me. Okay. Well, then if you take that, and let's go back to our office, then you have two real space. One space that we call the ergorama, which is the place that you execute your visual task. Ergo in Greek, means work. And here you needed to ensure that your visual performance is highest for your task, and also you need to eliminate any nuisance. What this means nuisance? Any reflection, any glare, dazzling, or I don't know what other in that space. Then you have the panorama, what is all around you, and here you have to eliminate any nuisance from that space. What can be straight light from the windows, can be what is in the lateral surface here. For example, say that I put here a very nice picture of sand beach with coconut trees and the sea, and I'm tired, I don't want to work. There are big chances that I will look at the picture and I will not execute my work. You have also taken into account what is in the different surface, what is the contrast between the surface, what is coming from the ceiling. If your focal object here is a calendar, but if it is the beach photo is not a good idea, and things like that. Here we have a mix between ergonomics and lighting, but they are very strongly connected. And then you have those two spaces, but those two spaces, they are not disconnected. You have to take into account the liaisons between the two spaces in order to ensure a luminance balance between there, and also the compatibility between the two spaces. If one is very bright and the other is very dark, could be problematic. There is an example. This is a photo now. And in fact, what is recommended is inside the ergorama never has ratio of contrast higher than 3. Objects inside your working space has not to be more than 3 times brighter than others. And now, if you take the panorama, then the luminance ratio, the contrast between ergorama and panorama, should not go higher than 10, and also inside the panorama, the luminance cannot go higher than 10, the luminance ratio, because once again you have a single object that becomes predominant, and you see only that. Your eye is attracted to the brighter object. From where the light is coming also is very important. Usually we put the light on the roof, or sometimes we put it on the wall, but we eliminate the roof. In fact, there is still here a reference to heaven. We know that a lot of light, especially bright light, is coming from the sky, whatever is behind the sky. Okay? And here you see some experiments that we expose people in different illuminance levels, low to high, and also the proportion of light coming from above and light coming from other directions. Okay? And what you see lower the light is, people prefer that the light is coming from above. Okay? Yes, this is some advice from where the light is coming, direct from above or indirect. This is the result of what I showed you before. And then you can find here some recommendations about how much light you expect to get at the optimal conditions for your working space here. Light coming from windows, from ceiling, from the furniture, for the reflections and things like that. A second very important effect, which is a nuisance, that reduces your visual capacity and also your visual performance, is the glare. When you are dazzled due to different causes, then you lost visual acuity, and also you can be in very dangerous situation. You know that when you drive and you have a car coming in the other side with highlights, you don't really like, because you are dazzled and you don't see really what happened around you. Well, the glare results from viewing condition in which one experience is different from another, and in fact it's very difficult to measure glare because it is a sensation. It's not a measurable phenomenon like a current or like a temperature. Glare you cannot measure. It's something that is a feeling. You feel glare, and it's very difficult to understand what is the feeling to each one, but we know that we have two types of glare, which is the direct. Here you are exposed to an intense luminous flux. You are in the front of the window, or here you are glared by the screen here, or you can have indirect glare, which is caused just by reflections. Here you see the reflections of the light bulbs on the screen, and in the place that you have the reflection, you don't really see what is behind the reflection. Or here you can be glared by the reflection of the fixtures on a very nice polished floor. Glare equal danger. You understand why? Look what is doing the guy here. He's drilling. His hands are not very far from the device. And if he is glared by the light here, or by the window, or by a reflection in a metallic piece here that can push him to not see correctly, instead to drill the mechanical piece, can drill his hand. Okay? Well, glare can cause discomfort. This is the first thing. When you are glared, you close the eye. This is not very complicated, but of course can affect productivity. And when the light that you get, the luminance that you get in your eyes due to glare is higher than 10,000 candelas per square meter, the glare is no more affordable. And you can go even in extreme situation that you can feel pain because you have a lot of light penetrating your eyes. How we can quantify? We cannot measure glare, but we can quantify glare. And we can quantify, thanks to the work of CIE once more, using that we call the glare index. And this glare index is given here and define a number of classes. And these classes, they are linked to the difficulty of the task that we need to execute. And you will see how you use that. For example, if we are here in premise in which people do not have a fixed workstation, they move around, they perform tasks in very low visual demands and things like that. For example, in a library or I don't know what, in a store area, you have a glare class E, but if you go in highly demanding visual task, like careful electronic assembly, you are in premises that they need a glare index A. And I will show you how we will use that. In fact, from where is coming the glare? The glare is coming either by direct luminance coming to your eyes or reflection coming to your eyes. If you look the three fixtures here, this one cannot produce direct glare because it's above your head or behind, but can produce indirect glare. This one can produce direct glare but not indirect, and this one, the B, probably doesn't glare you. Okay? In fact, when you are seated and you have a number of fixtures, which one is the most dangerous for glare? In fact, the most dangerous for glare is the fixture that you can see without moving your head. Here we have three light sources. If I am here, that one I have to move my head, that one also, but that one I can see it just looking with my eyes without motion. That means the source that you have to avoid to be able to see directly is the further one. And if you assume that your eyes, they are just on the wall and the source is just in the coin here, then you say, what is the angle gamma here? That above that angle, I don't have to have any fixture present. This is the problem to solve, how I can calculate that angle in order to be sure that not any of those fixtures here are glaring. Yes, maybe I have to reorganize somehow my slides, but okay. This is some metrics given by different organisms. I can go fast. And this is the more interesting for us. This is the way that you can find which is the maximum angle. Beyond that, you don't have to find any fixture. When you take the catalog from the luminaire fixture manufacturer, they give you, of course, these graphics, the polar plot, but they give you also that graphic that we call the Botman's and Solner ABAC, and there is, and you see here there is this is coming from the manufacturer. How you use this abacus? You say, for example, okay, there is the behavior of my fixture, bought by that manufacturer, and then you have to look, for example, this fixture, I will put it in a room that I have a glare class B, because I'm performing rather a difficult task, and the regulations told me for my room I need to have 300 lux. Then I follow that line here, and if the blue line is below that one, no problem. I can put as many fixtures I want. They will be never glaring. But now, if for the same GLAR class B, the rules tell me that I need 500 lux and not 800, look, if I follow that line, oops, here I have a part of the blue curve which is above the limit, and here in the intersection I can find the famous angle and say above that angle, above 60 to 65 degrees, I should not put any of those fixtures. If I take another fixture with a different curve, maybe I can do it, but if I select those fixtures, and if I'm in that situation, fixtures that they are 65 degrees and higher from my line of sight, they are glaring. Another interesting effect, the shade, the correlate color temperature. Okay, if I show you that that picture here, you will tell me this is a warm space because I use warm colors, because the fixtures, they produce warm white light, 2700 kelvins, and the regulations told me for an office space like that one, I need 300 lux on the working area. Okay. Now, if I show you that one, you tell me, wow, this is a cool or cold atmosphere. I produce high CCT light, cold white or neutral white. And here the legislation and the regulation told me I need 300 lux. But if I put 300 lux, all of the workers there, they will complain that they don't have enough light. And then you start to increase a little bit the illuminance level, and to get the same satisfaction rate, you have to go to 800 lux, which is almost 3 times more than what the regulation is requiring. But you have either to comply with the regulations and pay less energy and have happy workers. Happy workers equals high productivity, or pay more energy and have pay less energy, sorry, and have unhappy workers. It's as you prefer. In fact, this phenomenon has been studied by a guy working for Philips in between the two wars, Kruithof. Unfortunately, he is dead very young, and his work stays not fully completed. But Kruithof proposed these graphics here, this abacus, and he correlated the color temperature with the illuminance level. And he divided the space in 3 areas. The first one here, you have an excess of blue and green radiation. You have very cold white light, very cool white light, and people usually complain that they are in twilight situation and they don't like. On the opposite, here, there are excess of reddish, yellow radiations, and people complain that the space is very warm, and they are feeling even warm in reality. Here in India, in Nagpur, it's very hot. You prefer to have cold white temperatures, because for you it's problematic if you put warm white. Okay? If you go to Denmark, usually they use warm white because outside is cold. And finally, you have the yellow area here. That 95% of, or 99% of people says, this is fine. Don't touch it, it works. This is what I want. Just a point, in lighting you will never have 100% of satisfied people. If someone one day comes and tell me I have 100% satisfied people, I don't believe it. Because each one of us has his own experience, his own life, and we cannot be all of us agreeing, especially for such things like lighting. Okay, how you can use that? There is, say for example, I am in a room that I need 400 lux. Okay, the office that I showed you before. How I can achieve 400 lux? I have different technologies. If I'm a little bit crazy, I can do it with candles. Candles, they have very low correlate temperature, and to achieve 400 lux, you will need thousands of candles, but in that case, even in reality, it is hot, okay, not acceptable. I can do it with warm white LEDs, or I can do it with cold white LEDs. The result will be the same, 400 lux, but here and there people, the workers are not satisfied, there the people is okay. Well, in that situation it's better to use warm white. And just a reminder, the cooler the atmosphere, the more light is needed to be satisfied. Why that? Why that? Because human being has a very intimate relation with light variation. And I will discuss about that, and then we break for today. We continue tomorrow morning. Well, what is our relation with the light? Not only with the light, but also especially with the variation of the light within the day. We can discuss also between the seasons, but inside the day, what happens when you have sunrise due to the diffusion characteristics of our atmosphere. You have low light with shadows, you have non-uniform lighting, and also warm light, yellow, reddish. When you arrive at zenith, the sky is blue. I'm speaking not overcasted sky. In that case, you have less shadows because the light comes from above. You have larger quantity of light and much cold light here. And when the sun starts going down, same thing, you arrive to have more shadows. That means less uniformity, lower light levels, and higher and lower correlate color temperature. And in fact, this variation of light in 24 hours affects directly the production of some hormones inside our body. For example, when we are here, the melatonin secretion in the level of our brain is almost zero, and melatonin is the hormone that is linked to the sleepiness. And then, on the opposite, when melatonin is suppressed, our organisms work always that way. There is another one who is emitted, which is the cortisol, and the cortisol is the hormone that makes us alert, is the alertness. And this is also linked with our body temperature. Here our body temperature is normal one, around 36 something. And when the sun starts to go down, then our eyes say, okay, it's time to prepare for sleep. Melatonin production is increasing, cortisol is decreasing, our corporal temperature is decreasing, and we want to go for sleep. What means that? This is our normal rhythm, okay? What means that? Means if you have artificial lighting systems and you use different color temperatures lamps, you can affect directly, if you expose for more than a few minutes, you can affect the production of melatonin and cortisol, and in that case you can disrupt your circadian rhythm. You can force yourself to stay awake or go for sleep when you have to stay awake. How that works? In fact, since 1996 is very recent, we discovered that inside our eyes, beyond the cones and rods that serve to see, there are another kind of photodetectors, the EPGRP. I don't try to say the full name, it's unreadable. There are very few, that because we never see them before. And in fact, they trigger another non-vision circuit passing through the hypothalamus here and then going to spinal spine here and back to pineal gland, and the pineal gland here is controlling the production and suppression of melatonin and cortisol. That means when our eye detects that the sundowning, gives the order to brain to pilot the gland here, the pineal gland, in order to produce sleeping hormones. You see, a few years ago with incandescent lamps, any kind of lamp was warm white. And warm white doesn't influence you the night when you are exposed to that light. But now you go to the supermarket and you buy such kind of lamps with cold white because you feel better because of the outside temperature, and you put this cold white light nearby your bed and you use it for a couple of for a half hour, or I don't know how much. What will happen? The bluish light that you will get from that lamp will suppress the melatonin instead of leaving the melatonin increase, and it will be very difficult for you to sleep. You will try to sleep, you can arrive or not, and the next day you will wake up, will be tired, will have headaches, and all that phenomenon is not a problem with any electromagnetic radiation coming out from the lamps and the drivers from the lamps, but it's an electromagnetic radiation problem. Yes, you select the wrong light. On the opposite, if you take a very cold white light and you put it under your shower in the morning, taking your shower for 10 minutes under that light is the equivalent of 2 cups of coffee. Caffeine has exactly the same effect that cold light in the production of cortisol and suppression of melatonin. That means you have to understand better how the lighting system works, because some years ago this kind of problems doesn't exist. In that room here, I don't have the interest to put a warm white light because you are almost inactive, you take notes, you are looking me, you are looking the screen, and somehow you may want to sleep. If I add warm light, I can guarantee that a certain percentage of people will sleep inside the conference room. Okay, and also blue light may have some hazard. I told that at the beginning. The first hazard initially is that you may have circadian disorders. If you are not exposed to the right light for a normal period inside the day, you may have seasonal depression syndromes, and this happens for people that living in north areas in the earth, when the day duration is very small, maybe 4 hours in the 24, and as those people, they are missing enough natural light, their hormonal system is perturbed, and we can have depressions. A way to solve this kind of depressions is to make phototherapy by exposing people to artificial light for a given duration of the day, but you have to be very careful. Then there is another problem, is the blue light hazard. Blue radiation, I told that a few days ago. If I use the blue laser that I had last time in your eye, I can destroy completely a part of your retina. This one produces blue light, but the luminance is low, and you need to stay exposed for several days before having problems with your retina. You need to be exposed more than 1 year in the blue sky, with looking the blue sky without interruption, no blinking the eyes, in order to have problem in your retina. And then the lamps can be responsible for other kinds of photobiological hazards. Is when you have infrared, then you can burn a part of your eye, but this one can happen only with some special halogen lamps. This one can happen with very cool white LEDs and also metal halide lamps with very high flux. And that one can happen with metal halide lamps, can happen with black lights, what black lights I will come back, or xenon flash lamps, the UV hazard. Black light is what? Is when you go to a discotheque and you become, especially when you have a clear suit, you become fluorescent. Is because you are exposed to UV radiation at 380 nanometers, which is produced either by fluorescent lamps without the white powder and using silica tubes and not glass tubes. Silica allows the UV to come out, and or this is you get when you do some sun tanning using machines. This is very, very dangerous. We try today to forbid sun tanning machines because they can be responsible for cancers, skin cancers. Okay, that means, yeah, okay, you have glare, you have photobiological effects, you have effects on our own well-being. All that you have to take into account in order to be able to light up something. And in fact, and then we break after that, to make lighting, you need science and technology, fundamental science, engineering also. You need to take into account constraints, I told that. And you need a little bit art. And here you have the citation from Le Corbusier, one of the most known French architects. He is dead now. I don't like really cite him because it seems during the Second War he was not to the right side of the people, but okay. He said architecture is the learned, correct, and magnificent game of volumes ensembled under the light. Architects, they are not engineers, they are artists, first of all, and here Le Corbusier understood very well what is the importance of light in order to light a space. Okay, I propose to break here, and tomorrow we'll see now how all those things are going together in order to be able to light up a room, a stadium, a parking, an office, a retail store, and things like that. Okay? Well, thank you very much, and see you tomorrow at 10. And then also we finish that. Some things about environmental impact of light, which is also very important, and after a very short examination also, because you need to validate the module, and for that you need an examination. I I tell you from the beginning, it will be not complicated.